547. And it's f of xy equals e raised to x squared minus 2x plus y squared minus 4y and plus 2. Make sure I copied everything correctly. So x squared minus 2x plus y squared minus 4y plus 2. Okay? So we're asked to find, it says, find the relative max, relative min. Relative max or min or a saddle point. We don't know for this function. Okay. So in step number 1, remember we have to find all those first and second order partial derivatives. So we will have to find fx, fy, fxx, fyy, and fxy. So let's find fx first, which is the f with respect to x, the partial derivative of function f with respect to x, keeping y fixed. Okay, so this is e to u. It has to be e to u multiplied by the inner function prime. So I differentiate with respect to x. So it's 2x minus 2. This is fixed, goes away. This is fixed, goes away. This is fixed, goes away. Fy, which is df over dy, is the same thing, e to u to that function, multiplied by the function prime, differentiated with respect to y. Everything else is fixed. Fixed, fixed, fixed. So 2y minus 4. At this point, let's find fxx. So I have this function. Now I have to be very careful because this is a product. So I differentiate the first function times the second function plus the first function times the second function prime. So let's start. E to u prime is e to x squared minus 2x plus y squared minus 4y plus 2 times the inner function prime, which I know it's 2x minus 2, multiplied by 2x minus 2, so I'm going to put squared here, plus e to that x squared minus 2x plus y squared minus 4y plus 2 times the second function prime. Now fyy. This is fy. Now I have two functions. I have to apply the product rule. So e to u, I copy it. Times the inner function prime with respect to y, fixed, fixed, fixed. So 2y minus 4 times the second function plus the first function times the second function prime, which is 2. Finally, one more. Any questions? Let me stop for a moment. Any questions on this so far? Any questions? Okay, so I have to go back to fx or fy, doesn't matter, but let's say I go back to fx to differentiate it now with respect to y. Again, it's a product of two functions. I differentiate the first with respect to y. So it's e to x squared minus 2x plus y squared minus 4y plus 2 times the inner function prime, fixed, fixed, fixed. So 2y minus 4 multiplied by 2x minus 2. However, if I were to write plus this times this function prime with respect to y, that will be 0. Okay, so this is like a constant in front of this because it does not depend on y. I'm differentiating this product with respect to y, but this is a constant. It doesn't depend on y. So when I differentiate e to all this, I have e to that times the inner function prime with respect to y. Fixed, fixed, fixed. So 2y minus 4. Okay, so now we have all the partial derivatives. At this point, we move on to step number 2, in which we create the system. Fx equals 0 and Fy equals 0, and see what happens. Okay. So from here, Fx equals 0. I'm going to factor out 2, x minus 1 times e to whatever equals 0. And now I'm looking at Fy, 2, y minus 2, e to that whatever equals 0. E to whatever can never be 0. You can simplify by dividing both sides by it. It will never be 0. No matter what power. Remember the graph of e to the x is this. E to anything. If the top is positive and if the power is negative is this, but still will never be 0. So you can divide by it. So then the system reduces to x minus 1 equals 0 and y minus 2 equals 0. So the only ordered pair that we are talking about is 1, 2. So our analysis is on this point and nothing else. Okay. Moving on with step 3. In step 3, we have to determine d. And remember, d is fxx at 1, 2 multiplied by fyy at 1, 2 and minus fxy at 1, 2 but squared. So that's d. So let's calculate it. And if you remember, there are three possibilities: 0, negative, or positive. Okay, so fxx, where is fxx? Right here, this monster, okay? And 1, 2. I'm gonna come back to this. I need to calculate it separately. I may need more room, so I don't want to squeeze it in there. So I want to find fxx evaluated when x is 1 and y is 2. Okay. So e, 2, 1 minus 2 plus 4 minus 8 and plus 2 multiplied by 2. Oh, look at that. 2 times 2 is 4. 4 minus 4 is 0. So this is 0. Nice. Plus 2 in front. And this is e2. Again, 1 minus 2 plus 4 minus 8 plus 2. But this is 0. And let's see what we have here. Can I simplify anything? Yes, I can only simplify these two. Okay, so this is 2e to negative, what is it? So negative 3, I think. Okay, this was fxx. Now fyy, when x is 1 and y is 2. So it was 5. Yes, I think it's correct. Good. So now I want to evaluate fyy. Okay, so when y is 2 again, did I evaluate correctly? No. No, careful. Careful, careful, careful. I think I evaluated, I plugged in yy instead. I have to go back 1 second. So this doesn't change. This is still 2 to negative 3. This, oh yeah, this is 0. That's okay. Yeah. That was 0. Everything okay? Yes, everything okay. And now I'm evaluating yy. So that will be 0 again. Yes. 2 times 2, that's 0. And this is still 2, and this is still the same thing. It should be, because it's the same function. and the 2. And this was 0 because it was 1. This was 0 because y was 2. And in both cases, we have the same thing. Yeah. Okay, finally, so I have these two. I'm going to put them in here. So 2e to negative 3 times 2e to negative 3, and then minus. Now I have to determine this. Where is fxy? So it's right here. Let's see what happens. When y is 2, this is 0, and the whole thing is 0. So this is 0. You don't have to write 0 squared, but I just want you to know that I determined that. So this is 4 divided by e to the 6th, which is definitely a positive number, which means this could be a max or a min. Remember, if d is 0, it's a saddle point. If d is less than 0, the test is not applicable. So this is saddle, and this is not applicable. So only when d is positive, we can find a max or a min. But now it depends on the sign of xxx. But since the sign of xxx, we already know, was positive, so fxx at 1, 2 is positive, it clearly states that 1, 2 is a relative minimum. In case we're asked to find the relative minimum, 1, 2, this is the relative minimum. And I can go back to the function and plug it in. And we already plugged it in. So it's e to negative 3, which is 1 over e to the 3rd power. Because we already calculated with 1 and 2. We got negative 3. Is this what you had in mind? A calculation of a relative min or max for a function of 2 variables?
Yeah.
Good. We didn't see this function last time, so I think it was a good exercise. Good. Anything else you would like to work on?
Can you do like a similar problem to like one of the quizzes?
Oh yeah. Yes. Yes.
Okay, so it's from quiz 4.3 and 4.5.
Okay.
It's like from question 1. Can you do like something similar to that one?
Yeah, let me see. I don't have it brought it up. It's not brought up. I don't see it. So you said 4344. Let me look. 4345, you mean? You probably said that. Yes?
Yeah.
Okay. And you said problem 1.
Mm-hmm.
Okay. I just clicked on the quiz. Let's see. Question number 1. Yeah, these are the definite integrals. Sure. So let's say the integral from -1 to 4, from x squared plus x to the 3rd minus 4x dx. We find the antiderivative, which is x to the 3 over 3 plus x to the 4 over 4 minus 4 x squared over 2, and from -1 to 4. So now we plug in the upper limit. So 4 to the 3rd divided by 3 plus 4 to the 4th divided by 4 will be 4 to the 3rd power. This is 2, so 16 times 2 is 32. Minus -1/3 plus 1/4 minus 2. And I have to calculate all this. So 4 to the third is 64. 4 times 4, 16. 16 times 4, 64. And 1/3 plus 1 is 4/3. So 4 to the fourth over 3. Minus 32. Minus. So plus 1/3, minus 1/4, and plus 2. Okay. So I guess the least common denominator will be 12, and this will be negative 30. So, so this is 4 to the fifth minus 30 times 12, 360, plus 4 and minus 3. So the least common denominator is 12, so I multiplied the top here by 4. I multiplied this by 12 because I took care of 2. I multiplied this by 4, I multiplied this by 3. So 4 to the fifth minus 360 and plus 1. 665 over 12. Is that okay?